Welcome to MVC Concept Chemistry. Dear students, after watching this full video, you will be able to answer the questions on methods of preparation of haloalkanes and haloarenes. Students, in this video, I am explaining example, in-text and exercise problems. Watch full video. If you have any doubts, please mention in comment box. I will reply. Students, if you need any other particular concepts from different chapters or whatever it may be, that please mention in comment box. I will explain according to that. I will prepare one video. Students, now this question from NCERT example question number 4, students, they given like this: write the products of the following reactions. Means they given 3 equations, we should write the products for this equation. Once remember, students, this concept where we discussed methods of preparations of haloalkanes from alkenes, hydrocarbons, alkenes. There I explained, if unsymmetrical double bond is there, HBr addition reactions will undergo according to Markovnikov addition rule. There one simple point I told you, how to remember Markovnikov addition rule. Students, poorer become poorer, richer become richer. Means here, where is the more hydrogens are there hydrogen will attack. Where lesser hydrogens are there, their nucleophile Br minus will attack. That simple trick I given students. The same, if it is the peroxide is there, opposite to that simple trick I given students. Now, here students, more hydrogen side, hydrogen will attack, less hydrogen side, Br is attacking. That opposite side, peroxide is there, opposite to that is called anti-Markovnikov addition rule. Is the Markovnikov addition rule, this is the anti-Markovnikov addition rule. Now, here also, here peroxide is not there, unsymmetrical double bond is there, HCl is there, that is the Markovnikov addition rule. Here also, more hydrogen side hydrogen, less hydrogen side halogen will attack. Right, students, products. Now, what is the expected product here, students? Hydrogen side, hydrogen, the pi bond is breaking, students. The pi bond is breaking. Here carbon, already 2 hydrogens are there, 3 hydrogen, third hydrogen, this hydrogen also attacking here. That's why pi bond electrons are migrating to this side, students. This carbon atom is getting the negative charge. Here positive charge, negative charge. H plus will attack on the negative charged carbon. Now carbon valency 4 is there, students. Next, here already hydrogen is there. Here positive charge, carbon losing the electron, positive charge, there Br is attacking. Br is attacking, students. Same way, here students, this is opposite to Markovnikov addition rule. Opposite to Markovnikov addition rule. That's why here product, students, here product CH2 opposite to the students. Here CH2, here CH2, Br is the product, students. Students, this question they asked, why is sulfuric acid, in-text question, students, here they asked, why is the sulfuric acid is not used during the reaction of alcohols with Ki, they given, students. So, why we are not using sulfuric acid during the preparation of haloalkanes from alcohols? They asked a question like this, students. Why? Students, here sulfuric acid is a strong oxidizing agent. Ki, here iodine is acting as a strong reducing agent. That's why here instead of formation of haloalkanes, they are giving iodine is giving, students. That reaction we will discuss here. Now here, students, 2 moles of Ki, here 2 moles of Ki, when it's react with H2SO4, students, when it's react with H2SO4, it gives K2SO4. 2 potassiums are replacing hydrogen, students, plus 2 Hi product we are getting, students. 2 potassium replaced 2 hydrogens. Now, here, students, that 2 moles of Hi is there, not the 2 moles of Hi, when it's react with, again, is supposed to react with alcohol, students, but it is not reacting with alcohol, it is directly again reacting with sulfuric acid only. Because it is the strong reducing agent, it is a strong oxidizing agent. That's why what happening here now, H2SO4 again when it's reactive with 2 moles of HI, 2 moles of HI, it is converting into I2 plus 2H2O plus ESO2, it is giving students. Now students, you know that here sulfur oxidation state plus 6. Here iodine oxidation state -1, here sulfur oxidation state plus 6. Here iodine oxidation state 0. Here sulfur oxidation state plus 4. Now you see students here, sulfur oxidation state decreased from plus 6 to plus 4. Iodine oxidation state increased from -1 to 0. Oxidizing agent means itself reducing, oxidizing others. Now here plus 6 to plus 4 oxidation state decreased means itself reduced, oxidized others. That is the oxidizing agent. Reducing agent means students, reducing others, itself oxidation. Here itself oxidation means here oxidation number increased, you see, -1 to 0. 0 is the highest oxidation state, then -1. That's why reducing agent means reducing others, oxidizing itself. Okay, that's why in this reaction students, we can't prepare the iodoalkane students. That's why starting of this preparation methods I explain students, while we preparing the iodoalkanes, we are using H3PO4 and HNO3 oxidizing agents we are using students. Instead of this H2SO4, this point there I mentioned already students, once you can see the previous videos. Now here students, that's why here we are using that word students, Ki, when it's reactive with, students, that preparation method also I'm explaining once here, Ki, when it's reactive with H3PO4 students, H3, up to here, for this question, up to here answer is enough students. That's extra. How we are preparing iodoalkanes also I'm explaining here students. Ki plus H3PO4, it gives students KH2PO4 students. KH2PO4 it is giving students. KH2PO4 plus HI is giving students. Now it is the in situ. In situ means highly reactive and less stable HI students. Immediately it will react with C2H5OH gives iodoalkane. C2H5I plus H2O it is giving students. So like this method we are using to prepare iodoalkanes. This method here, this one is not, sulfuric acid is not suitable to prepare the iodoalkanes. Please note down students. Students, next in this question, write the structures of different dihalogen derivatives of propane, they ask students. Different dihalogen derivatives of propane. First, what is the propane structure? Prop means how many carbons students? 3 carbons. So CH3, CH2, CH3 is the propane. To this propane, dihalogen derivatives they are asking. Dihalogen means 2 halogens. Where, how many possible products we can write with dihalogens, they ask students. Now here, how many possible products are there students? Here, only on this carbon, 2 halogen atoms, 1 product. Only 2 halogen atoms on this carbon, 1 product. Students, these both are same students. Here any one side it is enough. Next, here one, here one. Next, here one, here one. Okay, like that possibilities will be there students. Okay, now here students, what are the possible product means? Dihalogens mean, this side I am writing students halogens, X is the halogen students, CH, 2 hydrogen replace it with 2 halogens, CH2, CH3 students. This is the one product. Okay, na? Next, second one students, middle carbon atom if you take. Here, X, here CH3. X is equal to halogen students. Now I told you this carbon or this CH, this side CH or this side CH3, both are same only. Next, third one students, third possibility, here CH2X, here one halogen, CHX, here one halogen, like this we can write. Students, these both are the geminal students. These both are the geminal. This is the vicinal students. Previous video I explained, while you are writing the IUPAC nomenclature, vicinal and geminal important students, that nomenclature. Next, here students, fourth one, we can write it as a CH2X, CH2, CH2X. It is not a vicinal students, not vicinal compound students, not vicinal students. Students, here no need what is the vicinal or geminal to explain here. Just once I am recalling students, adjacent carbon atoms attached with two halogens means vicinal. Adjacent carbons not having means that is not vicinal. Actually, just I am revising that concept, students. No need to discuss here. But what they asked, what are the different dihalogen products? Dihalogen products, how many possibilities are there? 4 possibilities are there. That is enough, students. Like this type of structures, if you write, it is enough. Okay? Please write down. Next, students, in this question, among the following isomeric alkanes, molecular formula they given C5H12, students, identify the one that on photochemical chlorination, they are giving this yield, students. The compound which is having a molecular formula C5H12, we should write these isomeric products. With the molecular formula, we should write these isomeric products. One compound should be with only single monochlorination, and another compound with 3 isomeric monochlorides, and one compound with 4 isomeric monochloride derivatives. We should write, students. Monochlorination means, students, only one halogen atom replacing one hydrogen. Okay, generally here that is the CnH2n plus 2 formula, students. Alkanes undergo photochemical reaction, students. That we will discuss now. Monochlorination, students, in the given compound, all carbon atoms are same, all CH3 groups are same, then only we can get the single monochloride product, students. That we will discuss, students, here. Suppose if it is there like this, CH3, yes, CH3 is there, students. Now you observe here, how many 5 carbons are there? C5, 4 into 3, 12 hydrogens are there, means this compound satisfying that molecular formula. And also, students, here all CH3 groups are same only. So now chlorination, if it is happened here or here, all the 4 carbon atoms are same only. Now here, students, plus Cl2 in the presence of H nu, it will give only one type of product only, that is a single monochloride product only, it will give, students. That answer here we can write like this: CH3, here CH3, here CH3, CH2, Cl. Is Cl, if you add here or here or here, all are same only, students. First question answer completed. Next, second one, students. 3 isomeric monochloride products should come. Means what? 3 different carbon atoms should be there now. Now, here, students, if you observe CH3, CH2, 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 CH3, students. Here, how many carbons are there here, students? You see here, these both are same, primary. The remaining all are secondary, students. Now equal priority, this one and this one same. Next, middle one no, different. Okay, now here, students, plus Cl2, if you add in the presence of H nu, students, it will give the products like this, students. Students, I am writing here bond line structure, students. Bond line structure means we can write like this, students. CH3, CH2, 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 1, 2, 3, 4, 5 carbon, students. This is the CH3, CH2, 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 CH3. 1, 2, 3, 4, 5 carbons are there. 1, 2, 3, 4, 5 carbons are there, students. Means third answer also you can write it here if you write the bond line structure, students. Now here students, chlorination. Monochlorination means what I told students, E both are one type, students. E both are one type, this is different. Third one. Now here students, products we can write like this. Students, chlorination if you do here or here, both are same, only one side I am writing, students. 1, 2, 3, 4, 5. 5 carbons are there, one chlorine atom added. Next one, students. Next one, students, here if you write the chlorine, this side or this side, both are same only, students. Next, here students, chlorine atom, here we are writing. Now here three products, three possibilities. What I told students, these both are same. That's why one side I written. Next, these both are same. Here I written. Middle one same, different like this. What is the name of this compound, students? 1-chloropentane. 1-chloropentane. It is a 2-chloropentane. It is a 3-chloropentane. See students, all three different, no? Like this we should get. Same way, third one, students. Third one, 4 isomeric monochloride products they are asking, students. 4 means what? Here like this, 4 different types of carbon should be there. So that's why here we can write like this, CH, CH3, next CH2, CH3, students. This one, bond line structure, we can write like this, students. Like this, students. CH3, CH3, CH, CH2, terminal CH3. Now, here, students, monochlorination. How many products they are asking, students, here? 4 possibilities. 4 possibilities they are asking, students. 4 possibilities, we can write like this, students. Here, one chlorine atom, students, 1, 2, 3, 4 carbon atoms are there in the root word. 1, 2, 3, 4. Here, chlorine, students. One product. Second one, students. Here, chlorine we can write, students. Third one, here chlorine we can write, students. Fourth one, students, we can write here chlorine, students. Here we can write the chlorine, students. See now, 4 products are there, 4 different. Means students here, this one separate. These both are not separate, students. Here second position methyl group is there. All compounds names you write, you will get the clear picture. What is the difference here? This is different, this is different, this is different. These both are same now. Terminal position, 2 CH3 groups are same. These both are same. That's why one side only I written the product. Please note down, students. So now in this question, first monochloro product means only one halogen derivatives. Here 3 isomeric monochloride means 3 products. 4 isomeric monochloride means 4 products. Be written, students. Please note down. Next, these reactions, students, they given here. Draw the structures of major monohalo products in each of the following reactions. They given, students. Here they given the equations. According to that, we should write the product, students. Try, students, already previous we discussed the concepts. Once recall the concepts and try to write the products. So these all are the preparation methods we already discussed, students. This is the Darjan's reaction, SOCl2. Major products we will get, students. Byproducts are the gases like I explained. Now here, OH group is replacing by chlorine, students. Byproducts are the SO2 plus HCl's are the byproduct, gases byproducts. Pure chloroalkanes we can prepare by using this one, students. Next, here, students, Br2 heat UV sunlight they given means reaction, reagent is suitable for alkanes. So now Br2 heat UV light they given means that is a photochemical reactions. Previous question we discussed, no? Like that. Now the reaction will undergo on alkanes part. Okay, now here the product, students. Here it is the NO2. Here, students, 2 carbons are there. In these 2, which is more stable? Radical will form here secondary radical. That too, benzene ring next carbon means that is a benzyl radical is more stable, students. The product will form here CH, here Br will attack here, students. It is the CH3 is the product. Halogen atom will attack on a more stable carbon, students. Next, here HCl plus heat. HCl plus heat, students, just replace the, here two H groups are there, students. Here it is there, here it is there. Previous we discussed now. Here benzene ring directly attached with OH means due to resonance structures, this OH bond is a strong bond. O and carbon bond is the strong bond. That's why here reactions will not undergo, students. Only on alkane part only the reactions will take place. Now here the product is, here OH same like, students. O and C bond is strong bond due to back pi bond formation. Now here that possibility not there. That's why OH group replacing by halogen atom. Then byproduct is the H2O is the byproduct is coming, students. Next, here students HI, Markovnikov addition rule we discussed now. According to Markovnikov, just HI and heat. Previous HBr and heat. Previous problems we solved, students. Like now here HI they given, students. Only heat they given means that is what, students, Markovnikov addition rule. Where is the lesser hydrogens, their iodine, more hydrogen side hydrogen is attacking, students. Okay, now less hydrogen side iodine, more hydrogen side, here hydrogen is attacking. Here one hydrogen is there, here no hydrogen, that's why iodine is attacking. Now here this is what is the Neymar reaction, students? This is the Neymar reaction now. In the presence of, what is that? Dry acetone. What is the product here? Just replacing bromine with iodine. CH3, CH2, I plus NaBr is the byproduct. NaBr is the byproduct. Now here also, students, heat, this one, heat and sunlight they given means the reaction will undergo an alkane part, alkane part. Students, double bond next carbon atoms are called what, students? Allylic. Yesterday we discussed allylic carbons. Now here allylic carbons are more stable na. That's why here halogen atom will attack on the allylic position. Either here or here, both are same only, students. So now these products we are getting. These are the products for the given question, students. Please note down. Now, students, some more problems on this concept from exercise, NCERT exercise problems I am explaining, students. Now, here question they ask like this, student. The hydrocarbon C5H10 does not react with chlorine in dark, but gives a single monochloro compounds in bright. In bright means sunlight, students. Identify the hydrocarbon they mentioned. Students, generally, here C5H10 formula means either alkene, CnH2n formula, either alkene or cyclic compound. Suppose cyclic compound, if you take, students, C5 carbons means cyclopentane is there. 5 carbons are there. 1, 2, 3, 4, 5 carbons are there. Each carbon will be with 2 hydrogens. 5 2s are 10 hydrogens are there. Now, if this reaction is undergoing in the presence of bright means sunlight, students. H nu, UV light. Is there no previous problems we solved now? Now, alkanes will undergo reactions in the presence of sunlight or UV light. Okay. Now, here, students, temperature also will possible, students. Bright sunlight, UV light they given means the reactions will undergo in a alkane part only. Now here the product, students, all corners same only na. All corners same means one chlorine atom replacing one hydrogen, like this products will form. Monochloro compound, only one possibility. Monochloro means only one possibility. This product only is forming. This is the answer, students. Other, why not, sir? Alkanes. Other structure of this molecular formula, students, we can write like this: CH3, CH2, CH. That is what CH2, CH double bond, CH2. Now see, 1, 2, 3, 4, 5 carbons are there. Hydrogens 5, 5 plus 5, 10 hydrogens are there. But here, students, it is the one carbon. Alkane part is there. Here also it will involve the reaction, students. The 1 is the 2. Here 3 possibilities are there. But he asked only monochloro product. That's why this is not a suitable reaction. Suppose one more, CH3, CH, double bond, CH, CH2, CH3, like this if you write it also. Here also 5 carbons are there. Here also 5 carbons and 10 hydrogens are there. Here 1 possibility, here it is a 2 possibility, here also 3 possibilities we are getting. Like this. But he asked only monochloro products, no? That's why only this reaction is the correct. These two compounds are not giving this answer. Okay? Please note down, students. Students, in this question, they asked, write the isomers of the given formula. They asked students. Isomers. Isomers means, students, how many possible compounds we can write with this molecular formula. C4H9Br is there, students. Solution, students, here we can write CH3, CH2, 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 4 carbons are there, 9 hydrogens, 5 plus 4, 9 hydrogens are there. Here Br is the one possible structure. Second one, we can write it like this, CH3, CH3, how many carbons are there, students? Generally here, how many? 4 carbons are there, na? 1 completed. Next, CH2, CH, Br, CH3. Is the 1 bromobutane, 2 bromobutane, completed, students. This side, here or here, both are same only, no? Here or here, same. Here or here, both are same only, students. Again, if you write one more structure, CH3, CH, Br, CH2, CH3, if you write it also, both are same only, no? Either this one or this one, both are same only. Or this one or this side, same. Okay, only 2 possible products will come, students. Okay, please write down, students. Next, in this question, students, write the equations for the preparation of iodobutane from these compounds. They ask the students. Now, here, students, we can write this. First question, butanol, students. In-text questions today, in this video only, in-text question, first question I explain, students. Butanol to alkanes, means alcohol to iodoalkanes preparation, same like this. Here, one butanol structure, students. But means how many carbons? 4 carbons. CH3, CH2, 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 OH is the butanol, students. Okay. If butanol, students, when it's react with Ki in the presence of H3PO4, H3PO4 gives iodobutane, students. This class we discussed, students. Here H3PO4 is a oxidizing agent. It removes the formed, first it initiate the HI. In situ HI is forming, that is highly reactive. Immediately it will involve in the reaction. Like now here, students, CH3, CH2, twice CH2, OH is the compound. Here 1, 2, 3, 4. 4 carbons are there. This is the product, students. Next one is the second one, students. 1 chlorobutane they given, students. 1 chlorobutane means CH3, CH2, 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 Cl. Iodobutane we should prepare. What is the named reaction, students? Frankelstein reaction. Frankelstein reaction. When it's react with the Na in the presence of dry acetone, it gives, students, CH3, CH2, 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 I plus NaCl is the byproduct. Iodobutane is the product. Next, third one, students. Third one, they given but1ene, they given, students. But1ene means here CH3, CH2, CH double bond CH2 is there, students. It is the but1ene structure, students. but1 when it's react with HBr in the presence of peroxide, anti-Markovnikov fission rule, students, then product is the CH3, CH2, CH2, CH2Br we are getting, students. This one further reaction with NaI in the presence of dry acetone Frankenstein reaction, students, it gives the iodobutane, CH3, CH2, CH2, CH2I, iodobutane. Like this, we are preparing this iodobutane, students. Please note down. Next, students, in the NCERT exercise questions, question number 14, they given preparation methods and chemical properties both together they given, students, but only preparation methods I am explaining here. After completion of chemical properties, the remaining questions I will explain. See, students, here in this question, only these 4 are there on preparation methods. Now here, students, first question they asked, it is what is the name of reaction? Till now we prepared, no? Frankenstein reaction, students. Previous video I explained these concepts all, students. Once you watch that videos, you will get the clarity. Then you solve these questions. CH3, CH2, CH2I plus NaCl is the byproduct. Next, this Darjan's reaction. Okay, good yield of alkyl chlorides we can get. CH3, CH2, CH2, Cl plus SO2 plus HCl. Byproducts also important, students. Sometimes this concept very important equation. Many times repeated in exams. Why here byproducts are both are gases, easily it can evaporate, pure chloroalkanes we can get it. Okay, next peroxide is there, means anti-Markovnikov fission rule. CH3, CH2, CH2, CH2Br, anti-Markovnikov fission rule. Markovnikov fission rule, students, more hydrogen side hydrogen, less hydrogen side bromine. Opposite to that one is the anti-Markovnikov fission rule. Then here product, students, CH3, CH2, here C, here students CH3, here CH3, here Br is there, students. So like this we can read this product, students. Till now, what are the questions are there in preparation methods? All I completed in this video, students. Please note down. Students, through my videos, I am explaining NCERT textbook clearly with more examples. After completion of particular topics, immediately what are the problems are there in NCERT textbook? Example, Intext and Exercise, that problems I am explaining. Please watch full videos. If you have any doubts, please mention in comment box. Subscribe the channel, like, share it with your friends and classmates. Thank you.